Good afternoon, everybody from all around the world. My name is Manos Panausis. I'm an associate professor at University of Greenwich, and I have been asked today to manage and facilitate this fascinating discussion with 4 experts in the field of cybersecurity. I think you don't believe I'm in Golden Gate Bridge, but I'm using this background as our topics actually are highly innovative. And the title of our panel discussion is Network User Security and Privacy Solutions in the New Era of Artificial Intelligence and GDPR. We have 4 presentations from our panelists, and I'm going to ask them to introduce themselves in a moment. Very importantly, I will be happy to convey some of your questions to our panelists for a further discussion. So the panel has been established as a joint effort of our 4 projects funded under Horizon 2020, and specifically of the Research and Innovation Staff Exchange, or else RISE action. They all focus on key cybersecurity aspects. You can clearly see their names here, and we're going to find out more in a moment about Seconto, INCOGNITO, Master, and Behave API. So, our panelists today, we have Dr. Nikos Passas from University of Athens. Nikos is going to talk about cyber threat intelligence. We have Professor Christos Xenakis from University of Piraeus, who is going to talk about qualified anonymity using anonymous credentials. Third panelist is Dr. Chiara Renzo from CNR. She's going to talk about user privacy in mobility data. And finally, we have our last presentation, Dr. Adrian Francalanza from the University of Malta, talking about security and privacy aspects of an API economy. So just for you to know, each panelist, we're going to spend 15 minutes on the presentation. And at the end, we will have around 25 minutes for questions from your side. So please post your questions in the chat. And I think it's time to start. So we don't lose time. We have 4 interesting presentations to see here. And I'd like to start with Dr. Passas. Nico, we are ready to start whenever you're ready as well. And thank you all for being here, of course.
Hello from my side as well. Thank you, Mano, for the nice introduction. I'm really happy to participate in this panel for the 4 projects. We are working in the same area. I will try to set the stage also for the next presentations and start discussing on cyber threat intelligence and measures to accomplish that. But first, let me say a few words about the motivation, what cyber threat is, and why it is so important nowadays. Most of us working with the internet and network services are experiencing an increase of cyber crimes, especially since COVID-19. There has been an increase of 300% according to recent surveys. This may cost up to $6 trillion by 2021. There is a significant increase in security breaches the last 5 years. Also, ransomware is a very serious problem that can top $20 billion by 2021. In fact, we have a ransomware attack every 14 seconds. Small or big attacks, and you can find a billion of passwords and emails in the dark web for sale. Maybe your email, our email is for sale. There are sites you can check this, like haveibeenpwned.com. We need data. We need to exchange information. In many cases, sensitive information. information, critical information for our work. And if we don't protect it, then the machine of the 21st century, that data is the oil to work with, cannot operate properly. So this is what cyber threat intelligence does. Some recent attacks, just to know what we're talking about. You may have heard of NotPetya in 2017, a ransomware where users were asked for $300 to regain access to their computer. This costs a lot of money to big companies, and insurers denied claims because it was not covered by contracts at that time. Also, Marriott cyber attack, where more than 500 million guest records were exposed since 2014 or even earlier, and was just revealed in 2018. The reimbursements reached $71 million, and also fines were significant for violation of GDPR. There are also hypotheses like the Sen attack scenario, a ransomware scenario where cyber attacks in major Asia Pacific ports could reach $110 billion of costs. Most of them would not be insured. And finally, maybe not that big attack, but it shows the flaws of the system. The Simon Weckert fake traffic jam, where this guy got 99 cell phones traveling around empty streets and creating fake traffic jams in Google Maps, showing that no system is secure. So definitely we need to protect our systems against all these kinds of attacks. And what cyber threat intelligence does. Usually we divide the operations of cyber threat intelligence in 4 main stages, forming a cycle. First, we need to acquire data. Without data, we cannot work. Internal sources, how our organization works, what are the procedures, the data exchange within the organization, the users, what the services they're using. But also external sources like open source, the social media is a significant source, also human intelligence and the dark web. After getting the data, we need to analyze them. For this, we have many tools like artificial intelligence to make predictions and extract insights. The data analytics, we need to analyze raw data and make some conclusions and predictions. And also machine learning, because in many cases we miss some data, significant data. So we need to predict and find some representative values to fit our instruments, our tools. After analyzing the data, the third stage is the intelligence. We need to take actions. So we need to detect the threats based on the analysis we did, understand and evaluate the organization status against the threats, and finally respond and prepare ourselves. This is first to mitigate the risk, take measures, defend ourselves against the risk that we have identified. And to the extent that this risk cannot be covered 100%, we have to transfer the risks. This means to insure ourselves, insure the data, insure the case of being attacked by someone outside, and have a contract that can reimburse and cover this threat. And since this is a continuous process, threats are coming all the time, the organization is changing, the data we're exchanging changes. Then we need to continuously run these processes, reassess the risk levels and the performance of the implemented security controls, and make corrective actions or even change the procedure entirely if we need to do so to protect ourselves. So we need to run this cycle at least as often as needed, depending on the changes of our organization, the type of attacks we are facing. What are the challenges in this process? The challenge mainly is that even though a significant percentage of people understand the importance of threat intelligence, 85% in a recent survey, around half of them say that they have not made progress against threats and how to treat them. So we need to change or to adjust the organization accordingly, create a proper team to manage CTA activities, experts that can work in this area. We need to have the adequate budget to work with this group, access to sources, but also access to all points of intrusion. I mean, this team has to have full power to be able to defend ourselves and the organization against possible threats. So the team has to understand what is the motivation of doing such an important work, which is the infrastructure that we are protecting, and what are the methods that are available. Finally, we need to integrate cyber threat intelligence within the organization with security information and event management, firewalls, intrusion detection system. In this case, we will close the gap between identifying that there is a threat and actually protect ourselves from that threat. This is what we work with in the Secondo project. It is a European project with 4 universities and 4 small medium enterprises. We started January 2019. We're in the second year of a 4-year project. It is funded under the Research and Innovation Staff Exchange, RISE Action, and Marie Sklodowska-Curie Action, and the Horizon 2020. And the funding is about covering the mobility of researchers within the partners in order to perform the work of the project. So what we do is that we try to design and implement an economics of security as a service that we call the platform in order to perform 3 major things. First, to estimate cyber risks inside an organization based on quantitative approach, recommend optimal investments about the identified risks in order to perform efficient risk management, and finally, determine the residual risk and estimate the cyber insurance premiums, the costs of insure ourselves against the risks or the percentage of risks that cannot be protected against. We have concluded so far to our architectural design, the Secondo platform, what we call that. As you can see, the main modules of this platform follow one-to-one the 4 stages of the CTI cycle we saw before. So we start with the quantitative risk analysis module number 1, to identify the vulnerabilities of the system and estimate the risks that we are facing. Then we have module number 2, cyber security investment, to model the attacking scenario, derive defensive strategies and costs about these scenarios. To feed the 3rd module, the cyber insurance coverage premium module, that actually estimates the insurance and creates what we call smart contracts. The insurance contracts that is the agreement between the insured and the insurer about the coverage, the coverage against the cyber risks. Finally, module number 4, continuous risk monitoring module, is required, as we said, for the continuous run of these procedures to keep up to date against new threats. As you can imagine, there is a lot of information flow from the outside and within the modules. I cannot say all the details, but in general, we need external and internal sources to feed the first modules that create the risk assessment and the pricing of the assets. Then to feed the second module for designing the scenarios and defending strategies and the costs for the scenarios. To finally create reports for the smart contracts that are finally stored in a blockchain infrastructure. We use blockchain because it's very convenient for our needs, distributed, secure database for not allowing changes in these smart contracts. A lot of tools and methods are used for this platform, so to acquire data, to do phishing, log files, the social media, etc. For analyzing specific data analysis and risk analysis tools like Pandas and Coras, maybe some of you that are familiar in the area can recognize the tool tools I'm referring. For the intelligence, optimal decision method, Solidity as the language for smart contracts. And finally, for the continuous risk monitor, the blockchain and the Ethereum implementation blockchain that allows the storage of smart contracts. And for use cases, we will investigate in this project, involve 4 major areas that we identified as weak in terms of security. First, Internet of Things. Recent surveys say that there is typically an attack every 5 seconds in the Internet of Things devices. Second is the airport infrastructures, because usually they have data exposed in the dark web and outdated web software. The third case is the cyber insurance for SMEs, small medium enterprises that don't have the capacity to protect themselves against all cyber threats. And finally, the maritime industry, because again, many hack attacks happened, especially in the last year in this area. So by investigating these 4 use cases, these 4 areas, we will try to prove the effectiveness of our platform. Of course, this is a challenging task. We need to have accurate data to be efficient. Without data, there is nothing that can be done to predict the scenarios, to perform optimal risk assessment and threat mitigation, and basically to adapt to new changes and needs. In short, to have a continuous risk monitoring that detects, prepare, prevent, and protect the organization. And finally, reduce the cyber security budget. We don't just use methods to mitigate the risk, but also create the smart contracts that is the insurance of the organization, that if something happens, okay, we will try to avoid of all the attacks and be very up to date. But if something happens, we need to know that there is an insurance contract that protects us, and we need to have the cost of this contract in order to be fully protected. And this is one of the innovations of this project. So I would like to close. I have 1 minute left in my 15 minutes of fame to say that we all need to ask ourselves some questions that are specific per case, per organization, per individual that accesses the internet, because the needs are different. We need to ask, what is the top cybersecurity concern we have? If we have enough resources to address these concerns, these threats. If we have a disaster recovery plan, if something happens, can we recover ourselves? Can we recover our data? Can we be updated? If we have known vulnerabilities and be secure aware, if we have a security team in big organizations to be able to defend a cyber attack. Why we would be a target? Some organizations by nature are a target to cyber threats, so they need to be more protected compared to others. And finally, how much a cyber attack will cost us, and if we can afford it. By answering these questions, we know what needs to be done. So Secondo tries to help answering these questions and be a tool that helps the individuals and organizations not need to know all the details, not to be experts in the area, but have a tool that by providing the correct feed can propose defensive measures and insurance contracts that provide the required level of security and insurance. I have consumed all of my time, I believe. Thank you for your attention. This is my email address if you want to contact me directly. And just to let you know of our presence in social media, Facebook, Twitter, and LinkedIn, and also our website for all the latest information and documents of the project. And finally, once again, thank the Commission and the RISE Action for the funding and the opportunity to work in this project. Thank you very much.
Thank you, Nikos. It was a very interesting presentation. We all appreciate cyber threat intelligence brings together a number of cybersecurity challenges, and that was interesting to see. We'll keep all questions at the end, and we'll move to the next presentation from Professor Christos Xenakis. Christo, please start your presentation when ready.
Okay, thank you, Manos. Thank you for the introduction. I would like to thank you also the organizer for this invitation for me to participate in this very interesting conference and this very interesting panel. The topic of my talk today is about qualified anonymity, a work that is carried out in the INCOGNITO project, the second project that participates in this panel. And if I'm trying to, with one sentence, to explain what is qualified anonymity, actually qualified anonymity deals with a trade-off between the information the necessary information that you have to reveal, to give to somebody in order to get access or to get a service, and from the other side, preserving anonymity. Let's see now why anonymity is important. Anonymity is important because it restricts mastering on others. The less information that someone knows about ourselves, he has the less power on us, because information is a power. Also, privacy protects freedom of social and political activities. And we're witnessing now a lot of activities and a lot of discussion about what is happening all over the world. A third very important reason is respect on human beings. With privacy, we respect the citizen, the society, and of course, privacy puts the proper boundaries among the society. So these are very four important reasons why we need privacy. The European Commission has recognized that and launched 2 years ago the GDPR. It's a famous law all over the world. And what is the main contribution of GDPR? First of all, identifies data collectors and let them disclose that they collect and process data, and they do this in the proper way. Demands for privacy by design solutions. So all the information system, everything should be support privacy by design or privacy by default by incorporating state-of-the-art anonymization, security techniques like encryption, anonymization, pseudonymization, and all that stuff. Recognize rights on the data subject. Every person has a right on himself, herself, or on the data that characterize the data subject. And also obliged for immediate reports of any data breach. So everybody should be aware if a data breach has been carried out. GDPR is applied within the European Commission, but also has inspired national law all over the globe. For example, in California, in Chile, in Japan, Brazil. And I would like to testimony my personal experience also in China. Everybody talks now about GDPR. I think is something that we export as a European Commission we export continuously all over the world. Let's see now how data privacy infringement can be carried out, can be performed. First of all, we have identity fraud. Identity fraud can be occurred by impersonation or false identification. Someone pretends someone else. As a result, we may have unauthorized access to online resources or data. On the other side, let's say another direction of exploiting personal data and violating privacy is the use of personal data. Personal data has value, and personal data are used as Nikos mentioned also, for research, for marketing, or cyber attacks. So it is very important to understand the value of this personal data and then find solution to protect them. let's see some real world cases that I think all of us are aware. Let's summarize them. First of all, in 2018, we had the big incident in Facebook, the reveal of big incident in Facebook with Cambridge Analytica, and how they process not in a proper way all the personal data, and this has an effect on the political developments in US. So it's a major case, recognized. Last year, in 2019, we had a big incident in Canva. Canva is a graphic design tool, a website, where it had been attacked, and as a result, we have the reveal of more than 4 million credit card and payment data. So it is also a major incident that cause financial, let's say, damage to the person and the application. This year we have the ICE case. ICE is a big telephone operator in Thailand. So this operator was hacked, and as a result was the reveal, the leakage of 1 million of DNS queries. And some will say, okay, DNS queries is not so important. Yes, it is important, because this leaked information reveals what sites, what websites each person, each subscriber of this operator visits or visited. And considering the fact that Thailand has a very strict censorship law, maybe a lot of people are threatened now by this law to have legal problems or to go to the prison. Last but not least, this year we had Etheras. It's a specialized application developed in Qatar in order to track COVID-19 infected person. This application has been hacked, and the result was the reveal of more than 1 million subscribers' personal data, including sensitive information which has to do with their health condition. So you can see how important all of this for representative cases, we can say, I have presented. Let's now move to some real world use cases where we don't have a malicious activity, an attack, and we have a reveal of information, but we reveal our personal information on purpose to get a service. Suppose that I am a student, I want to have a discount in a bookstore, and in order to prove that I am a student, I have to reveal my student card to the bookstore, either physically, if it is a physical store, or electronically, if this is an online store. So you can see in the screen the information that is marked in yellow is the personal information, the personal data that we reveal intentionally to this bookstore, which is the ID card, our photo, the institution that we are students, our name, our date of birth. So a lot of personal information. Suppose now another case that someone is in the drinking age, above 18 years old, for example, what happens in Greece, and he or she wants to buy alcohol. If this is not evident, if you are above or below 18, you have to show to the bar or to the supermarket your ID card. But by presenting the ID card, either in online or in a physical store, you reveal a lot of information, as I said previously, the ID number, the date of birth, the full name, the first name and the surname, and your nationality, your photo, everything. So we give a lot of information in order to have simple transactions, simple case, just to buy a beer. So what is a solution to this? Okay, a possible solution that our project and our research focus on. The name is qualified anonymity. Let me briefly analyze how qualified anonymity works. Actually, it divides, it separates the identity of a person into multiple attributes. For example, my identity consists of my name, my surname, my date of birth, my emails, my phone number, my driving license, my passport number, everything. All this information is our identity. So you divide all these attributes and you manage them, you process them separately, and the user is allowed to combine the necessary information, only the necessary information, in order to get access or to have a service. For example, when you want to buy alcohol, the online store or the physical store needs to verify that you are above 18. Nothing more, nothing else. So by this technology, we implement a solution that solution that is it's named attribute-based access control. Let's see how this can be implemented and how this is implemented within the INCOGNITO project. So in INCOGNITO, our objective is to provide a qualified anonymity infrastructure that combines three fundamental basic technology. First of all, cryptographic credential. As the name says, cryptographic credential is cryptographic function, is a cryptographic technology that transforms, let's say, encrypts our identity attribute, change their nature in a way that nobody can understand, but on the other hand, proves some specific property. For example, it takes my date of birth and creates a certificate that says, okay, that Christos Xenakis, he is above 18. He's a male, he's a researcher, he's a professor, he's a Greek citizen, or he's a European citizen. So you have only the information that is necessary in order to have the service. Moreover, our platform, our solution incorporates federated logins, federated state-of-the-art technology like OpenID Connect, UMA2, where single sign, it supports single sign-on. Is like how we use single sign-on solution. For example, using my Facebook or using my Google account, I can log in to a wide set of services. And also, we incorporate blockchain technology. Blockchain technology in order not to have everything centralized in a unique operator or a unique database, but to have everything distributed and have the ability also each user to maintain his personal ID and maintain the attribute of his or her personal ID. This is in line with a very, very recent trends. Perhaps you have heard the term self-sovereign identity is something that came to the state of the art of the bibliography 1 or 2 years ago. It's an exciting way how to deal with privacy and your personal attributes. And INCOGNITO shares the common idea, the common approach with this, the self-sovereign identity and the development of blockchain. Let me explain how qualified anonymity works in general and in INCOGNITO. Suppose that we have a user and the user wants to have access to a service provider. The traditional way is to register, to have username and password, but this is not the case for buying alcohol or for buying a book with discount. So let's assume that for this service operator wants for someone to give access to be above 22 years old, to be a student, and to be a European citizen. The normal way is for someone to let's say present an ID card or a passport together with a student card in order to prove all this information. But in this case, the service provider will have a full control of our IDs, student ID card and passport or our national ID card. let's see how this case now is improved, works with Incognito. We have the Incognito, which Incognito is an identity provider, is a mediator that can give us identity attributes in a certified way. So everything is certified. So the user has all this information certified, but using the Incognito platform and using the anonymous credential can transform the real identity attributes into, let's say, fuzzy identity attributes. For example, I am above 22, I'm a student, not in the University of Piraeus, but John Doe in the University of Piraeus, but I'm a student in the University of Piraeus, or you can say in the GR domain in Greece, and I have a European passport. And this information, we submit this information to the service provider in order to get access and get the service that the service provider grants to us. So in this way, we transform, let's say, we exclude, we change the information, and nobody has all this personal information for the data subject. Together with this, some other objectives, innovative objective of Incognito is that it supports the seamlessly acquisition of all the attributes for physical documents, for example, our ID card or our online identity. You can fetch, you can take all the identity attributes from the university identity provider or from Facebook or Twitter or Google or any other, or EIDAS, for example. And you can process this information through the Incognito platform. And also Incognito supports a user-friendly user interface supported by artificial intelligence in order to, for people that are not so familiar with technology, to help them to do everything easier. The incorporation of Incognito platform and the incorporation of anonymous credential does not require to change everything in the online world or in the physical world. We see, as you see here, we can establish the Incognito platform in the middle between the online service and the current identity providers, and to have this exciting technology without any change, without any interruption, in a seamlessly way. Here we have the Incognito architecture. As you see, there's a lot of technology and many issues. We're not going to implement everything from scratch. Actually, the main part that you can see here in my screen, you can see here in my screen, is outside the red circle. The red circle is what we have developed in a previous project. The name was RECRED. I was also the coordinator of the RECRED project. So in the RECRED project, we have developed an exciting and innovative identity management solution using FIDO, OpenID Connect, attribute-based access control, UMA2. So we have incorporated all this information, but Incognito has an important limitation. Everything was centralized. So in RECRED. So in Incognito, we have expanded this architecture by providing a distributed architecture based on blockchain. So Incognito extends RECRED development by incorporating blockchain and by providing an architecture in a distributed manner that also supports privacy and security by default. In the Incognito consortium, we are 6 partners from 4 countries, from Spain, Greece, Romania, and Cyprus, University of Piraeus, Cyprus University of Technology, CertSign, which is a Romania company, Elastic, which is a company based in Spain, Telefonica Research, a well-known company, and Focus, which is it's a Greek SME that is located here in Athens. And I would like to say that Incognito is funded by the European Commission. This is a RISE project, as Manuel mentioned at the beginning. And you can see also the information about the website and the social media of the Incognito project. Thank you very much for your attention. This is my email. If you have any question, I would be happy to answer.
Thank you, Christos. That was a very interesting presentation. I think after the Snowden's revelations, society is concerned about surveillance, and this comes down to what you're doing. And I will move to the next presentation, which is highly related to privacy as well. It comes to location privacy. And I would like Chiara Renzo, Dr. Chiara Renzo from CNR to start her presentation when ready.
Good evening, everybody. My name is Chiara Renzo. I'm from National Research Council of Italy in Pisa. I'm talking about user privacy in mobility data. So it's very related as previous presentation. But now we talk about mobility data. I think that many of you can recognize yourself in this video. Many people, and I'm one of these, are using our telephone everywhere, every time. And this means that we are tracked. So someone is tracking our location. We're using technology, not only telephone, but also large indoor environment like shopping mall, museums. They are somehow tracking our location. Think about the smart working. We are working everywhere, and even without our PC, when we access internet, when we issue a query on Google, we are leaving tracks of our position. Not to mention the autonomous vehicles also, or social media. All these movements are captured by the location device, can be the car, can be the telephone, can be the computer. What is in common is that this movement data is represented as a trajectory. A trajectory is a temporal sequence of location points. For example, in the case of GPS, like the telephone, for example, we have the location represented as latitude, longitude, and time, as here in this example. The sequence of all these points is our trajectory. We see in this example in the map, this road that red points are the tracks that we are living and moving. This track is a track of a person working, moving in Pisa. The collection of all this mobility data of moving objects, can be person, vessel, cars, trucks, animal, and so on, are collected by some service provider, can be the telephone company, a provider of the app we are using, on the social media, and so on. So someone is collecting this data about our movements. When we talk about mobility, it's important to mention that when mobility data are analyzed, we can have many benefits for the society. Think about the climate change. So if you analyze the transport data, we can find a way to reduce emission, to avoid the traffic jam, congestion, to improve the sharing, for example, to reduce the traveling cars. Not to mention the COVID, so also for health, it's important to study mobility data, since we can monitor and contain the outbreak in the pandemic case, but also in our many other cases. Not to mention other challenges like socioeconomic challenges, tourism, monitoring of tourism and recommendation for tourism, urban planning, security, traffic control, transportation management, and many, many others. However, when we talk about mobility data, we have to talk about privacy. According to GDPR, location data are personal data. So it is subject to the GDPR law. Even more, location data becomes sensitive data sometimes, because from the analysis of movement, it can infer sensitive information about people. So from the trajectory, I can see that this person is going, for example, to a religious place. So I can infer his religious preference or health status if he's going to the hospital or something like that. So it's very important to take care of privacy when we talk about location data. Okay, then we can say, okay, so location data can be de-identified. So the trajectory we said before, we just drop the name of the person. However, it is sometimes, very often, possible to infer, to re-identify the person. So infer the name, the identity of the person, even for a de-identified trajectory. It has been shown some years ago in a very famous Nature article that analyzing the location of spatial temporal location of people in a data set of GSM tracks, so mobile phone, they were able to identify 95% of people with only 4 points. And with 2 points, they can re-identify 50% of the user. So the message is the identified trajectory is not enough to protect privacy. Let's see an example here. It's the same trajectory as before. It is anonymous. They identify the trajectory, but then we consider additional data that are public. For example, in this case, we can discover that the point A, where the trajectory starts in the morning, 3 people are living. There is Anna, there is Marco, and there is Mario. So we don't know which of this person is the trajectory belongs to. Then we see the trajectory is stopping at point B to go to work. And then we know from the public records that at point B, there were 3 people working. So Anna, Giuseppe, and John. Then we notice that Anna is the only person that lives in A and works in B. So we successfully identify the trajectory as the trajectory of Anna. And this means that we are able to understand that Anna also went to the hospital. So now we identify not only, we identify the trajectory, but we also discover sensitive data from Anna. So linking location data with publicly available data source is possible to identify the person who left the track. A very famous case some years ago came from Bradley Cooper. What happened in 2014 is that the city taxi company in New York released a public data set for research purposes of the trajectory of the taxi in New York. They identify the trajectory, so we don't know the plate of the taxi, the name of the guest, the customer. So they just say the pickup point, the drop-off point, the time, the fare amounts, and the tips. So what happened is that someone mapped this information with public image of celebrities getting out of in of the taxi. And they were able to isolate the journeys of Bradley Cooper and Jessica Alba. So what they discovered is that a specific taxi ride were done by this person. So they discover where this person has been, how much they give for tips, and something like that. What we have to think about this is that if we can do this for Bradley Cooper, we can do for every person, linking the information about the public information about the the public information about the travel and the background knowledge. So the identification of the data is not enough. When we talk about interconnection of data, we have to think that we live in a world with highly interlinked data. And this is exactly the objective of the master project I've been coordinating. It's also a RISE project as the others. And in this project, we study method for analyzing trajectory data linked with other additional aspects. So in this example, social media, like in the Bradley Cooper, weather, traffic condition, news, and other kind of data. Of course, when we talk about data and when we talk about data enriched with other linked data, we have to talk about privacy. So what we have to do, we have to consider approaches, new anonymization methods for considering privacy for this kind of enriched data, so highly linked data. This project is also assisted by the independent ethics advisor, Professor Bettina Berendt, that supports us in all the ethics issues related with this data. When we talk about data anonymization, we talk about privacy by design, as already mentioned the previous speaker. So which is our objective is that some condition from the anonymized data set should not be possible to re-identify the individual. So this is the objective of the privacy preserving methods. I put here some, just maybe anonymity, diversity, obfuscation. Now it's very trendy, talk about differential privacy and many others. When we talk about privacy, we have to think about the classical big one question. So the privacy debate is always a trade-off. Should we renounce our privacy for the public good? Or put in other words, which is a good trade-off between privacy and data utility. So there is no one answer to this question. What I want to point out that in many cases we can preserve the privacy of the individual, but still have a good benefit for the society. So the point is that we have to study privacy preserving technology, algorithms, analysis method that find a good trade-off between these two extremes, so true privacy or too few privacy. Another thing that is important for the research in this topic is that is the role of this new technology and the research. Because if from one point of view the new technology, the new collection method, the new social media, and the spread of the information can increase the risk of re-identification, it's true that new technology, new research can study methods to increase the privacy preservation. So again, we have to find a balance between these two aspects. Another point that is also connected with the previous presentation about incognito is that maybe we can just collect as little data as possible. It's very connected with the previous project indeed, because here the idea is that maybe we don't need all this long time, the specific position of the person. Maybe we just need to collect less information. That is what we need for the application. This is the classic case of the COVID-19 tracing apps. I think you all listen in the news about these tracing apps. So essentially, most of them at least, they don't collect the trajectory, there is no location, no personal data. They just collect the encrypted ID of the telephone in a distributed way. So the risk of our privacy, let's say, is really minimized. We can call this Occam's in the concept of data collection and analysis. Another point that I think is important to discuss today is that we need to create a circle, a trust circle in technology. If we build a trustable technology, then we gain the people trust. And then with the people trust, the people is more willing to give their data, location data. And this means that we can benefit the society more for all the cases that I showed before, so health, climate change, and so on. So more trust means more data. That means to increase the trustable of technology. So I really think that we need to create this positive circle concerning the technology. Last but not least, ethics. When we talk about privacy, sometimes we confuse with ethics. exactly the same thing. So privacy is necessary. There is the law like the GDPR that embody many technical principles. So giving user access to the data, deleting data, and so on. What is the GDPR? But just because it's legal, it doesn't mean that it's ethical. So maybe we have the full consent to get the data from individual, but then we are analyzing, processing this data in an unethical way. So we really need a bigger picture about mobility data, also on the goals of the analysis. So privacy is not enough in this case. I was just to conclude, making some advertisement for our project. We will have a summer school, hopefully in person in Santorini probably in April. So if you're interested, please check. You can register to the school, and hopefully we can meet in Santorini next April. Then I can just mention about the project. We have 10 partners. As you see from the map, we have partners in Brazil and in Canada. That is really an issue because now we cannot travel to them. Here is the website, so you can go to the website to see what we are doing. And then if you have any question, please feel free to contact me or my colleague Beatrice anytime.
Thank you, Chiara. It was very interesting to see that services we want to use at the same time disclose our location privacy, and we have to decide what we're doing, especially if we're famous. And we'll move to the fourth and last presentation for today for our panel from Adrian Francalanza, Dr. Adrian Francalanza. Adrian, please feel free to start your presentation when ready.
Thank you for the introduction and also the opportunity. My name is Adrian Francalanza. I am from the University of Malta, and I'll be talking about security and privacy aspects for an API economy. I'd like to start by going over some of these beautiful buildings here. You might recognize the Duomo in Florence, or the Marlborough Castle, that's from Poland, Hagia Sophia, that's from Turkey. We have the temples of Banang from Myanmar, and then we have the Taj Mahal from India. And I'd like to ask you, what do you think that all these buildings have in common, right? And you may answer that they're all very beautiful, and I would agree with you, right? Meaning also that they're also very complex and very intricate, and that's part of their beauty. You might also say that they have been around for a very long time, and I would agree with that, right? Which means that they are probably also very, very robust. And the last thing, which I think is the theme of this presentation here, is that they're all built from bricks. So what's special about this humble brick? Well, the brick, you don't need any special natural resources to have a brick. I mean, you just need mud. With a brick, you can build very complex structures like the one we've seen, and you can build them incrementally, bit by bit, right? So when you have enough money, you may build the first layer, and then you may build the second layer next year, so on and so forth, right? And the brick, you can very easily replicate it, right? So it doesn't take a genius to form a brick, right? So you can farm it out, and other people, they can build the bricks for you. And more importantly, you can shape the brick yourself, right? So there, an important aspect of the brick is that it is smooth, right? Another aspect that often we take for granted about the shape of the brick is that it fits in one hand, and that's very important if you want to build a large building. Another aspect of its size is that typically bricks, the size of the width is half the size of the length. And this is very important if you want to build a structure like a brick wall, like you see there. It's actually the size and the outside, the exterior. It's very important for the strength of the wall. Okay. So what's essential, or at least what we'll focus in this talk about the brick, is the interconnections that make up the brick wall. I'm going to give you some other examples of bricks, right? So bricks, they haven't changed a lot over centuries, since the Romans and even before that. The only thing that has changed slightly, only slightly, is subtle differences in the exteriors and how bricks fit together. Here, these are 4 examples. And these small changes, they make sure that the interconnection and the wall, right, is very robust. Now, the exterior of the equivalent of a brick's exterior for the point of view of software is what we call the API. You must have heard of this. Essentially, it means application programming interfaces. And every software nowadays, right, must have probably has interface with some sort of API, be it OS, be it some web service, so on and so forth. And I'll first try to explain what these APIs are, because our project, Be Happy, focuses around essentially augmenting these APIs. So if you had to look at a piece of software nowadays, you probably see something like this. So software nowadays, it's not one big monolithic structure, but it's made up of small components, right? So in this example here, we have the tracking component, the billing component, the orders component. You might have some users database. You might have some products component shipping. And if I was a developer, right, typically, I would not be interested in how each and every component works internally. Most probably, I won't even have access to the internals of each component, because some of these are third-party components, right? But what I would see, it would be the exterior of these components, the API, so to speak. And if I want to understand how this piece of software works, what I'm actually really interested in as a developer is the interconnection between these different APIs. So what is an API? An API is like it is like an outer shell that wraps around a piece of software, and it has essentially two important functionalities. The first one is that it packages complexities of the internals of the internal software, like we say here. So, but at the same time, it also exposes part of the functionality of this piece of software, this software component, right, to the outside world. So some external piece of software can then use part of this functionality. And this is here denoted by these plugs here, okay? Now, to be able to use it, right, typically these plugs, they would provide you information in terms of what calls you can make to the software, right, how to make them, maybe some data formats that are expected of you, some conventions on how to call them, so on and so forth. Speak again of software nowadays, right? This is the picture typically that we see nowadays, right? So probably you must have heard the expression that software is eating up the world, right? So anything from fridges, mobile phones, public libraries, governments, text departments, right? Social media, radios, every single one of these entities nowadays is governed by software. And the other important thing nowadays is that all these software components, right, that are managing all these varied aspects of our lives, nowadays they're becoming more and more interconnected with one another. Okay, and how do they do this? Via API. So typically you'd have the radio software that exposes an API, right, that then your watch can interconnect with it, right, and then the watch can switch on the radio at a certain point in time. Okay, if I can go even further, right? Over the recent few years, we've seen the rise of what we call the API economy. What is that? So the API economy, essentially, it is you have this pool of components, each exposing their own API, right? And if, for example, you want to build your own, I don't know, you want to start your own startup, right? You don't have to build everything, right? You would build the core functionality, and then you would invoke APIs from other services, right? That they would give you the expertise that maybe you don't have in your current software. So what does this give you? What does the API economy give us? It gives us specialization, right? So I can just focus on my core expertise, and I can just build my own component, right? It avoids reuse, right? So if someone is an expert in building an API for Facebook, right, I don't need to recreate it myself to be able to advertise some new feature of my product. It improves your time to market, right? Because you don't need to develop everything. You can reuse things as a service, right? If you want to use some knowledge about maps, you would probably connect to some mapping API by Google, Apple, or what have you. And importantly, and this is very important, it lowers barriers to entry. So this has led to a number of new businesses that otherwise it would not have been possible to create in such a short time. So it's a very exciting proposition, right? Everything is interconnected. You might have heard of the Internet of Things, right? But at the same time, some might argue that this is also scary, right? So which side are you on? Well, it depends, right? In spite of the fact that this may be scary, right? I mean, this is like one big train. It's very hard to stop. Right? This is some data, right, that I have. I mean, I think I have only up until 2019. But if you look at the size of the API economy, right, it's been growing and growing and growing, right? And this is where we're going, right? So somehow we have to make sure that we take gain the benefits of this thing, right, without incurring the scary sides of these things, especially in terms of security. And this is precisely what the Be Happy project is trying to achieve, right? It is a consortium of 20 partners from all over the world, ranging from Argentina, the US, and a number of places within Europe. We have Portugal, we have Malta, we have Italy, we have Denmark. I think I probably must have forgotten a country or two. We are 20 countries. Sorry, 20 partners. And what we do essentially, we try to target these APIs, right? And we try to improve this technology, right? For a number of reasons. One of them is to improve the security of our software in order to make it more robust. So concretely, let me start. Let me give you some diagrams here, right? So our software typically would look something like this, right? Whereby you have the executable, right? And this is the blue boxes here. And then you would expose this API, which is this orange box, right? And via the API, then you can connect to some other API, this other orange box here, right? And what's important for us are going to be these arrows here, right? This is where we specify, for example, things like data formats. This is where we specify what kind of calls you can make on one another's APIs, okay? The picture nowadays tends to be slightly more complicated, and you would probably have something like this, right? So you'd have the API, and then you'd have your requirements list, right? And this is where something like GDPR would go, right? So, for example, in here you may require that, listen, don't send out my social security number, or, for example, only communicate my telephone number after this API authenticates itself. Another aspect could be, for example, if you are connecting with me just to gain access to my torch, right? I'm not going to give you access to the camera, right? Because there you can take picture of me without being authorized, right? Where does Be Happy come into play within this picture? Well, essentially, Be Happy comes into play when things go wrong, or it tries to prevent things from going wrong. For example, you might have problems in this section here, right? So for example, you might have a service, right, that is expecting a non-negative integer, right? But then you might send a negative one, right? Or for example, you might have a service that is expecting you to send the two numbers, two integers, but you only send me one, right? So what we do in Be Happy, right, we try to say, before you compose two APIs, we will tell you either upfront before you compose them or before you run your program, these two APIs, they are not compatible, right? Or this API is expecting something that this other API cannot guarantee. Or otherwise, we can actually say, sometimes you have this information before you run your program. So it is within the API. Other times, actually, you don't have this. So in this case, what we do is we would automatically generate what we call monitors, which are other programs that actually analyze the communication between two APIs and then detect when things go wrong. Sometimes they can also take remedial action to correct errors. Another place where Be Happy can play a role is when things go wrong in this section here, right? And this is actually very important, right? So, for example, you might have an API that might violate some GDPR requirement, and in this case, we can, via monitoring or via static analysis, we can actually detect this and try to launch corrective actions. The last place where Be Happy plays a role is here. So you might have an API, right, that on the face of it, right, might be all fine and dandy, and it might be connecting with compatible APIs, and it might respect requirements. But then you might have the program, which actually is offering an implementation for that API, and there may be bugs there, or the program may not conform to what the API is saying. So in this case, Be Happy would ensure that whatever program is implementing an API, it actually conforms to what that API is saying. And if not, we can either reject that program or try to correct it. And that's all from my side. Thank you for your attention. These are a few links that you may want to check. And that's it. Thank you very much.
Thank you, Adrian. I'm not happy that I misspelled your project, but Be Happy is doing interesting things. So I was happy to see your achievements. I think it's a good time now to move to some questions we have here, and I would like to start in the order we started this presentation. So I'll start from Nikos and INCOGNITO Project. And one question I would like to ask him is, Nico, do you foresee any collaboration among a good number of organizations and CERTs leading to a hub, let's say, of threat intelligence to support the organization in the future? So this is the idea of the hub, where we collect information from everywhere.
Yeah, definitely. I mean, it is clear that the issue of cyber threats is highly challenging and needs a lot of expertise. Imagine that we are experts, and in many cases we are considered ourselves experts, and in many cases we might find that we don't have enough protection against threats. You wonder, have I made the last update in my firewall? Am I secure enough? Do you have any new threats by email, by web? And we are working in the area. Imagine organizations that are not working in computers on the internet. They are in completely different sectors. How hard it would be for them to have a group, to be updated, to know that they are secure. So these kind of hubs are needed in order to conclude to common practices, to policies and guidelines, in order to help organizations and individuals that don't have and don't need to have this expertise to work towards this direction. And with tools like the Secondo platform that we are trying to implement, we try to assist towards these directions. So in this kind of hub, there is also a pool of tools and platforms that can help either individuals or organizations to create this kind of shield, this kind of protection against cyber threats, and not have to deal with all the details and all the expertise that needs to be obtained in order to work in this area. So I would definitely see that as a need, and hopefully there are international directions towards this.
Thank you, Nikos. Yes, so the answer is yes. It may be challenging, of course, to share everything in the way I have in my mind now and the question is posing, but yeah, definitely this sharing can enable a lot of good intelligence among the world. I will move to Incognito and Christos Xenakis. So, Christo, you mentioned at some point the self-sovereign identity, and someone here is asking whether you see this this self-sovereign identity concept with IoT being something innovative, but actually realistic to be implemented within the next decade.
Yeah. Thank you, Manos, for this question. I think you mentioned in the next decade. I think yes, this is the future. Of course, we need a lot of time to pass and a lot of research to be done in order to be able to provide a viable, let's say, solution that supports self-sovereign identity first for the humans, for the people, and then we can say in a hierarchical way. I imagine to have under the control of a human or of a persona to have a set of IoT devices that are related to the human person or to a group of humans. For example, we can share, if we use the same home or the same office, for example, we can share, let's say, the same IoT devices, and we can have a common control of them, and in both blockchain nodes we can have access to the attributes and to the operation of this IoT device. In order to conclude to this very interesting question, I would say yes. For me, this is the future. But it's not a future of the next couple of years, but I think it's in the next 5 or 7 or 10 years, I would see such a solution to be operational and to support our daily life work and activities.
That's great. So I think, yeah, it's a nice idea to start protecting our privacy more from surveillance, and then I can actually go to the master project and ask Chiara how. I know that you mentioned something about the COVID-19 application, but I would like to say any other location disclosure app that we may have in the future. And I'm not looking at the east of the planet, but it could help us. How does your project at the end of the day practically can help individuals like myself to not be afraid of using an app?
Thank you for the question, Manos. Yes, at Master, we don't really produce apps for the COVID because COVID was not known some years ago when we started. Anyway, I really think that the kind of analysis that we are doing about this enriched data. So it's really important that we find some solution that is really privacy aware with this interlinked data, because this we can give, as I mentioned in my slides, can give the people the idea that the technology is trustable, and so people is more willing to give this data. This is really something that probably you read all the time in the news about these COVID apps, which is the problem with the COVID app, is that they're not used, except the East country, as you mentioned. In Europe, in the US, they are not used because people don't trust the technology. They think they are surveilled, from the government, and this is really something that we want to avoid, to be able to use this technology for the good, so to predict an outbreak or to contact tracing. So I really think that this kind of input for the future, we can give this kind of thing.
Interesting.
And of course, then there are the other solution, because now everybody is talking about the COVID app because it's on the news. But mobility data and analysis of mobility data is also important for understanding the movement of people, so in more historical way, to understand how the spread of the virus, so for the past, but also to predict the future outbreak. So the mobility in the broad sense, not only with the tracing app, but maybe from the social media, for example, we have the flow of people from one country to another, so we can predict that there will be an outbreak because many people are moving. So there is several kind of other analysis that we can do on mobility data, privacy preserving, to try to help with the COVID.
That's interesting. Thank you, Chiara.
Yes.
I'll move to a question for Be Happy and Adrian. Actually, the question is, do you aim to increase privacy of what is shared through APIs beforehand, or the APIs themselves do something to increase the privacy of what you're sharing? I understand from the question that the APIs are external, so you don't have access to that. But I guess this question is trying to go down to how really the privacy takes place, the data privacy is taken care of.
Excellent question. Thank you for the question. Actually, so the current status quo is the following, is that we have the information, so we know what we should do to ensure privacy, right? The only problem is that this information currently, it's either written in English, right, in some document, right, or it's written in the source code, right, of the programs as comments, right? But it has not been what we call formalized. So it is not in a format that actually a computer program can then process, right? So what we are trying to do, and this is one of the main challenges within Be Happy, is trying to extract this information or provide the framework where you can manage this information, this privacy information. And the important thing to keep in mind is that this privacy information, it is not static. It evolves over time, right? So you may have a software that's been running for like 5 years, 6 years, but the privacy concerns, they change over time, right? So you need to update your privacy concerns. But once they are in a format that we call formal, right, then what we can do is we can manipulate them, and we can manipulate them in a number of ways, right? Typically, we can apply proof systems or logical analysis. So I didn't show it in my slides, but what we have advanced mathematical techniques to reason about things, right? Once you have them in a formal way, right? And there, I told you that we can tell whether two APIs, they are compatible, right? We can do it for very simple properties right now. We can, to the best of our knowledge, right, the current APIs, they do not carry out these things automatically in an automated fashion for things like security. So we plan to augment and extend APIs to have this behavioral information, right? We call it behavioral information. Security is just one aspect of it, okay? To be able to carry out this formal analysis. Once this data is in this formal representation, you can, I don't know, generate other programs. You can generate other programs that actually carry out the runtime monitoring for you, right? Once things are in this format, right, you can generate tests so that before you run your program, you can check for security leaks, right? So the main challenge is essentially to take this information and formalize it. Once we have it there, we can do lots of things with it.
Right. Thank you. It was quite a thorough answer. Thank you, Adrian. I have a question, not necessarily related directly to the technical aspects of your project, but actually how do you see the framework that the European Commission has in place to bring together researchers from universities and companies called RISE, Marie Curie RISE? So I'd like to see any of you who wants to talk. It would be great to see how do you see this framework working well for you. I'm aware of the time. We have 6 minutes only, and the organizer, I believe, is quite strict. So anyone who wants to start this, it would be great.
Mano, if I'm allowed, I can start with this. I would like to add something to you, not only between companies and the exchange stuff only between companies and university, but also between research institutions that are outside Europe. For example, I think Chiara's project, there is no company, but only institution that comes from US, from Brazil, or from Canada, and exchange stuff between European institutions, European universities. I find this this framework very helpful because let's say takes all this connects people with a different background, from a different environment, and puts them together in the same room or in the same place in order to work together and provide some meaningful results. For example, I can say for my projects that this is particularly helpful for both projects, for Secondo and for Incognito. For example, for Secondo, because we have a real user that is a cyber insurance company. So they want to, they put their knowledge in order to see, okay, how threat intelligence, risk analysis, blockchain, smart contract can work all together in order to have a cyber insurance product. And also in the other project in Incognito, how this exciting technology, qualified anonymity, that it's advanced cryptography, we can have this in a real use case. And this is very important because, you know, in a university we can work, we can develop algorithms, solutions that we need this solution to be applied, because only if a solution are applied, then they have future and they can be supported and adopted by the community.
I see. Thank you. Thank you for that. Yeah, it's quite clear that this is beneficial for everyone. If anyone else wants to mention something, we have
something, Manos.
Yeah, please.
Something. They're talking about RISE, not from the technical point of view, but about the experience of the project. As you see in the map, in my background here, we traveled to Brazil and to Canada. So I think that for the second year, especially the young researchers, the researchers, it is really an amazing experience. Sometimes the first time in their life they cross the ocean, they stay 1 month, 2 months, 3 months in an exotic country like Brazil, working in a research group there. So a completely different reality compared to Italy, compared to Europe. So I think that another value of RISE is also not only technical from the technical point of view, but also for the experience of the young researcher to see a different country, a different kind of work, research groups, experts from very different realities. So I think that in my experience, a coordinator, people is very happy also about this aspect.
Thank you, Chiara. I guess Nikos and Adrian are also endorsing this framework.
Yeah, so I was going to actually emphasize on what Christos said. So from our experience, be happy, right? The idea was that from the university, from the academic side, right, a lot of these solutions, like we thought that we have them figured out, right? But the feedback that we're getting from the industrial partners is invaluable, because there you know what they want, right? And vice versa. I think it's been also, I'd like to believe, quite useful for the industrial partners to know what technology currently exists and how then they can use it for their own case study. So I think it is a symbiotic relationship that goes both ways, right? Both from the academia to industry and vice versa. And it's been very positive for us.
Absolutely. Okay, then Nikos, if you have any last comment before we close.
You said everything, all of you. We have long experience. I worked with Christos maybe on both projects, Secondo and Incognito, and it's been a great pleasure to combine the experience of the academic and the industrial sector. So I think the possibility to actually not fund the work itself, but the mobility of the researchers gives the initiative to bring them all together. Because if you just fund the work, then everybody will be isolated like that through teleconference, which is great in times of emergency like now, but it's not the usual case, and we need to work together, to have the conference live, to have the group together. So this is great, and hopefully we will have more opportunities in the future. I stop here because I think we need to stop the session.
Yes, thank you all for being here. Thank you for presenting your achievements. You are all very well.
Thank you for the coordination.
Yeah. Thank you, our audience, also for watching this session.